长征1走。
并且呢，这个还特别复杂，还要
飞上太空。而现在呢，其实从我们的镜头当中呢，也能够看到啊，已经是一个准备就绪的状态。其实大家看啊，现在呢，整个的塔架，它呢。我们其实今天的直播呢，是从今天的16点就已经开始了。那个时候呢，其实火箭还是处在一个被塔架包裹的状态。从我们现在的镜头当中呢，不太能够看得出来。还是能看出来一点点的，就是这个下面呢，还似乎在冒着白色的烟雾，是有一点这个。如在仙境的这种感觉的，其实呢，这是因为啊，它在之前呢，它加注了这个氢燃料以及是液氢和液氧的燃料。这个燃料呢，它是一个极低温的一个状态，所以呢，在加注的时候，加注之后呢，都会出现这个相应的这种情况。而在加注之后呢，它也就是一个不可逆的状态，将会在之后再按照它的计划检查完成计划之后呢，完成今天的飞行的任务。那我们刚刚呢说到了这个塔架现在是一个打开的状态，它其实在打开的过程当中呢，也是经历了3个顺序，先是呢最下边的第1连打开，之后呢是上边的第2连，最后才是中间的上面的第3连，最后呢才是中间的那个第2连它来进行打开的。其实这样的一个过程呢，也是因为最后打开第2连，也是因为呢为了保证我们这个火箭中间那个位置啊，能够相对来说更安全一些。其实今天的天气呢，应该说现在，整个来说还是要温和了很多，风也小了很多。就下午的时候呢，那会儿风很大，而且我们也是经历了几次的这种，短时的这种降雨啊。可以说那个时候，其实我心里边还是有一点点紧张的。毕竟呢，虽然说对于我们这个870吨的火箭而言，可能这一点的风不算什么，但是总会担心，万一到发射的时间这个风变大了，我们该怎么办？但还好，其实现在呢，我们能看到啊，其实整个来说，现在的风力反倒是回到了一个比较稳定的状态，而且天儿呢也没有再有任何降雨的迹象。现在的温度呢，这边也是比较适宜的。我们所有来的这些观众们呢，也能看到啊，很多人也是选择穿了一个外套。毕竟呢，到晚上虽然说是在海南啊，在文昌，但是到晚上的时候呢，还是稍稍会有一点点凉的，何况是在这样一个空旷开阔的场地当中。火箭呢也，我们的镜头呢现在依然是给着我们的今天的主角，我们的长征5号。你好， 哎，打扰一下，您是从哪来的？
从北京来的。
从北京来的。
对对对。
那您是这个哪天过来的？
我们是今天
刚到，今天刚到，专门来看火箭发射是吧？
专门来看。
之前有看过吗？
之前没有。
之前没有。
对。
哎，您印象最深的一次发射是哪次？
应该是长5的第一次发射吧。
长5的第一次发射。
对。
那是什么时候还记得吗？
应该是
2016年11月。
对。
哎，您这记得是够清楚的。那您得讲讲了，为什么记忆这么深刻？
因为我的很多战友、很多朋友都从事这个工作。
哦，是吗？
对。
您是什么工作？
我们是做航天工作的。
您没做。那您是一直都一方面是因为自己的朋友们他们在从事这份工作，另一方面是自己也很喜欢这个，是吧？
对对对。对。
那这个您今天过来有什么想对长5说的吗？
长5，我们国家要发展壮大，长5必须离不开你。
为什么呀？
因为航天强国嘛，我们国家以前是失去海洋，不能再失去太空。长5是我们国家走向太空的必须的一个平台和工具。
好的，好，谢谢。其实刚刚呢，我们的这位到场的观众呢，他提到的说，这个对于我们发展太空来说呢，长5是必须的，确实是这样的。相对而言呢，长5它所要担负的任务要很重，包括我们现在这个探月的计划，这个嫦娥5号的发射，也包括在今年下半年的时候，当时发射的天问1号也是通过胖5来发射的。除此之外呢，还有未来的空间站相应的计划，也是要通过我们的长5来发射。所以呢，其实它在未来还要肩负起更多的重任。那时间慢慢临近，我们呢也期待着发射的那一刻。接下来呢，让我们继续把镜头还是给到我们的主角，还是给到我们的长征5号。好。我们也期待，我们也希望啊，今天的发射能够圆满成功。我们在这里，在场坪这里，和所有的观众一起见证。
角色里面，然后如果让您选择一个您最喜欢。
对，就来占座了。然后搭了5个帐篷
，5个帐篷。
对，5个帐篷，有几个同事还在里面休息。咱们一共来了多少？来了10多个人吧。
10多个人。
好的，那我们也一起预祝成武能够发射成功，然后在这儿能够有很精彩的，然后让大家看到很精彩的升空。
好嘞，
好，谢谢。我们再往这边走走看哈，其实刚才我们也看到了很多很多年轻的朋友啊。我们在这边，哎，这位帅哥，来，我们来采访一下。先自我介绍一下。
我叫杨浩，是来自南京的一名大学生，大4学生。
从南京来的？
对，从南京来的。
什么时候到的？
我是今天下午到的海口，然后今天晚上赶到的文昌。
是来到文昌之后直接就来到沙滩？
对，直接来到沙滩了，然后把相机架好，然后准备等待火箭发射。
那为什么会选择这个海滩来观看火箭发射呢？
第一是觉得这边环境很舒服，第二是因为这边我有一个长焦的镜头，可以直接照到那边的发射台，所以就是说到时候它如果起飞之后，就可以能够看到它一个比较完美的一个轨迹吧，就是所以
也是带着装备而来。
对，是的。
好的，那也祝福你待会儿能够拍出最美的嫦娥。
好，谢谢。
好。我们再来看一看啊，其实在这片海滩，我发现还有很多，你看现在人群越来越多，越来越热闹了。在那边还有专门为这次观看发射来设置了一个志愿服务台，然后在刚刚我们下台阶的那个地方呢，其实还有供电系统的一些员工来为供电应急做准备。其实我们也发现，在为这次嫦娥5号能够顺利发射，其实有很多人都是在默默地付出着贡献的。哎，我们看到，还准备了国旗。来，我想采访一下。好的，我想采访一下，你们是从哪来的呀？海口来的。
对，从海口来。
是专门就是为了看这次发射，然后特意赶过来的。
对的。
开车过来的。
开车过来。
应该还不远。
我们提前4个小时就过来了。
提前4个小时就过来了。
对的。
是每次一发射都会过来？
这是第一次。
第一次。为什么想着这次过来呢？
觉得作为党兵很有这种荣耀，很赞。
对，然后还特意带了一面国旗。好，非常好。好，那个我们一起预祝一下嫦娥5号能够发射成功。我喊，然后嫦娥5号，然后大家也一起喊加油，好不好？好，嫦娥5号，加油！好的。我们非常能够感受到大家的热情。哎，我们这边看还有几个小美女，哎呀，怎么回事？这么激动？来采访一下，大家是从哪来的？
我们是从北京
过来的。什么时候到的呀？
我们已经到了2天了，在海南一直等着这个发射。然后我们这一行人有100多人，然后那边有我们整个100多人休息的一个地方。
你们是一个怎么样的组织？
我可以做个广告。
那就算了。咱们是专门为这个火箭发射过来看这个嫦娥5号发射的。
10点多就已经到这儿了，然后一直等到现在。
那看来大家也是非常忠实的这个航天迷，对吧？
对，我们大家都在等。也是想跟着所有的这些朋友们一起见证这个历史的时刻。
好的，谢谢你们，祝你们今天开心。
谢谢。
好。我们看到真的朋友们都非常的热情。
海南师范大学晴天文社。
哎呀，来，有主动要求接受采访的。自我介绍一下。
大家好，我叫贾和，是海南师范大学晴天文社的一名成员。对。
然后
这些都是我。
你们。
现在大概几个小时了，对，是6点一下课，然后 绝对没有逃课。对。
那对这个待会儿嫦娥发射有什么样的期待吗？
就先预祝他成功发射吧。就是也希望中国航天能够越来越好，这样子。
好的，然后你们是专门的一个航天
我们是天文社团，然后对大学社团，然后我希望这次发射任务能圆满成功。对。
那咱们这个社团有没有口号啊？来一起预祝一下嫦娥发射成功。平时呢？
平时是吗？
平时你们社团有什么样的关于自己的这个理念上的一个口号？算了，没关系，咱们就一起预祝这个嫦娥5号能够发射成功。好的，也希望你们今天能够好好享受。
好，中国加油！
好的，
中国航天加油！
中国航天加油！
好的，非常感谢你们，
谢谢，
谢谢。我们看到其实除了航天迷之外，应该还有这边又看到一个帅哥，就主动要求采访，我看也是带了装备。
对，是带了装备过来的。我是来自苏州的大学生，然后我是专程来看这次长征5号运载这个嫦娥5号发射任务的。
我感觉你好像是这个经常会看火箭发射的是吗？我看装备都很齐备。
对的，我本身对这个航空航天也非常的感兴趣，然后祖国现在这个航空航天发展的也非常的厉害，所以我也因此感到非常自豪。所以我也经常因为一旦有这种活动，比如说像珠海航展，或者说像这种发射的活动，我会第一时间到现场。
你方便问你现在是多大吗？
我是98年出生的，今年22岁。
China's aerospace authorities say the spacecraft launched from Wenchang have some 10% higher carrying capacity compared to those launched from other sites in the country. It will also be safer to conduct lunar missions there, as fallen objects will drop into the sea, helping to avoid the evacuation of local residents. Rockets can also be transported by sea, so there won't be any size limit for their components. And now, let's bring in our guests, Professor Yang Yuguang of the China Aerospace Science and Industry Corporation and Xu Yansong from the Asia-Pacific Space Cooperation Organization. Gentlemen, I'm so happy to have you on today. Your expertise and analysis will be much appreciated in our special coverage. Professor Yang, I want to start with you. Let's talk about the Long March 5 rocket here. This is China's heavy lift rocket. It's larger in size, affectionately known as the Fat Five, actually among space program and rocket fans. Why do we need Long March 5 for this mission in particular?
Well, you see, Long March 5 together with the Long March 3A series are used for launching spacecraft with very high altitude. You know that Chang'e 1 and Chang'e 2 are orbiters to the moon, and both have the mass of about 2 more tons. So the Long March 3A and Long March 3C are powerful enough to launch this kind of spacecraft. Well, for Chang'e 3 and 4, because both landers are much heavier with a mass about 3.78 tons, so only Long March 3B can launch these payloads into the Earth-Moon transfer orbit. Well, for this Chang'e 5 spacecraft, which has a mass about 8.2 tons, it is already exceeds the capability of Long March 3A series. So we don't have other choices. Only Long March 5 has the capability to launch so heavy payload to the lunar orbit. And you see that Long March 5 have a capability of about 14 tons to the geosynchronous transfer orbit, while for an object to the moon will be about 8.3 tons. So this is already powerful enough for this spacecraft.
It has a lot to do with the weight of what you're carrying into this space. Mr. Xu, how does the Long March 5 compare with other heavy lift rockets that China has?
Well, China has the only heavy lifting launch vehicle would be Long March 5, and currently we're developing a new generation launch vehicle. But in comparison with international launch vehicles, we do have Ariane 5 and Falcon Heavy. which are comparative to the Long March 5. Each have different characters. The Falcon is using a single rocket engine, but with varieties of numbers, and the Ariane 5 is using solid propellant boosters, as well as liquid kerosene, and liquid oxygen and liquid hydrogen as a core. So the core is similar to Ariane 5, and similar to that, we also have the shipment, as the video have just mentioned, from Tianjin to Haikou but also in the European Ariane 5, they're using ships to ship the rocket to the launch site in French Guiana. So there are many similarities, but also there are big differences in terms of payload capacities, in terms of fuels and rocket configurations.
These rockets you mentioned, they vary and differ in size and in shape, and sometimes in the number of boosters they have. Is there consensus maybe on the reliability of a particular rocket?
Well, each rocket needs to have experiences, number of launches that counts in your account. For example, the Long March 5 is only the number 5 time for its launch, but the Arianes and the Falcons has many in their logbook already launched, and success and failures. So they have more experiences and expertise in the rocket configuration, rocket designs and details, and also softwares. So the Long March 5 is a new rocket, still relatively new, and so we need to have accumulation of number of launches to further increase its reliability.
All right, thank you so much. The Chang'e 5 mission is about to make China the first nation to collect lunar soil and rock samples in over 40 years. But what's the craft itself like, and what challenges does the mission face? For this, our reporter Dong Xue has the details.
No spacecraft has brought back moon rock samples to Earth since the last Soviet mission in 1976. China's Chang'e 5 will soon take on the challenge. The craft mission is to collect samples from Mount Rumeker region on near side of the moon and bring them back. The 8.2 metric ton Chang'e 5 is comprised of 4 modules: a lander, ascender, orbiter, and returner. After launching, Chang'e 5 will arrive at the moon after about 3 days. Once it enters lunar orbit, the lander and ascender combination will separate and descend close to the Mount Rumeker. This is a 1,300-meter high volcanic complex in the moon's northern region, made up of vast dark lava plains. Over the course of 14 days, the lander's robotic arm will scoop up surface samples, and a drill will retrieve cores down to 2 meters. Scientists are hoping to collect 2 kilograms of material. However, analysts say the mission is technically challenging and many things could go wrong. The lander could crash land or top over, and the samples could escape from their canisters along the way. The descent and ascent will take place over 1 lunar day, which is equivalent to around 14 Earth days. This brings up the question of how to avoid the extreme overnight temperatures that could damage electronics. The deputy chief designer of China's lunar exploration program says other challenges include the sampling and following stages, because gravity on the moon is about only 1/6 of the Earth's. Under such circumstances, the packaging of samples becomes a key issue which the mission has never tried before.
The Chinese lunar exploration program is an ongoing series of robotic missions. Its nickname, Chang'e, comes after a mythical figure who is believed to live on the moon. Let's now take a look at the milestones in China's attempt to explore the moon.
The ambitious Chang'e program started in 2004. It consists of 3 phases: orbiting, landing, and returning. The first goal is to orbit the moon. In 2007, China launched the Chang'e 1 satellite. After spending 16 months in orbit, The satellite successfully concluded its mission with a controlled crash into the lunar surface. The Chang'e 1 also obtained a full image of the surface of the moon. The Chang'e 2 was sent into the moon's orbit in 2010. As NASA notes, this marked the first time a Chinese lunar probe directly entered the Earth-Moon transfer orbit without circling the Earth first. It captured the world's first full lunar map with a spatial resolution of 7 meters, showing more details of the moon's surface. The second phase is to achieve soft landing on the moon and automatic inspection. The Chang'e 3 was launched in 2013. It carried with it an unmanned rover called Yutu, or Jade Rabbit, which in folklore was Chang'e's pet. It was the first soft landing on the moon since 1976, making China only the third country to achieve the feat after the US and the former Soviet Union. Next up, the Chang'e 4 mission started in May 2018, when relay satellite Queqiao was propelled into orbit. It was sent to set up a communication link between Earth and the upcoming Chang'e 4 lunar probe. It stayed in a geosynchronous orbit on the far side of the moon. 7 months later, Chang'e 4 with a lander and a rover went into space. After a month-long journey, the probe landed on the far side of the moon, which is never visible from Earth, and China became the first country ever to manage the feat. The Yutu 2 rover carried multiple equipment working as a CT scanner. It obtained deep lunar materials directly through on-site exploration, revealing the complex geological evolution on the moon. Chinese President Xi Jinping congratulated the country's scientists on this historic achievement.
太空探索永无止境，希望广大科技工作者、航天工作者。
There is no end to space exploration. Our country's scientists and engineers should ride on the wave of the Chang'e 4 mission to achieve the ultimate goal of China's lunar program. You should make more efforts to push forward the international aerospace exploration and bring more Chinese wisdom and power to the peaceful use of space and the building of a community with a shared future for humanity.
Now the Chang'e 5 will try to accomplish the third phase of the lunar program, a return mission to collect soil and rock samples back to Earth. Gao Yiming, CGTN.
And now let's continue our discussion with my guests, Professor Yang Yuguang and Mr. Xu Yansong. We just heard from the Chinese president who encouraged scientists to build on Chang'e 4 and strive for more achievements. If you look at China's lunar probe program in general, this program was inaugurated back in 2004, and now 16 years later, we're sending the Chang'e 5 probe to collect samples and return them from the moon. Professor Yang, how would you categorize China's achievements in the last 16 years, especially regarding the previous 4 Chang'e missions?
Well, to discuss this question, we should be aware that China is still a developing country. Although we've already been a very big country in space field, we have a very large-scale space industry, and we achieved the top 1 launch times this year and last year. But still, for a developing country, we still have only limited goal in this kind of scientific research. So you see, Chang'e 1 and Chang'e 2 use the very practical Dongfanghong 3 satellite platforms as a base. So it used only a little money to develop these kind of projects and achieve the goal of orbiting the moon. In this procedure, we master the technology of the Earth-Moon transfer and also the orbit insertion from outer moon. Because you see, if a spacecraft approaching the moon, if it do not have an orbit maneuver, it will fly by the moon and do not enter in the lunar orbit. So this is is a very critical point for China Aerospace at that moment. We mastered this technology from the Chang'e 1 and the Chang'e 2 mission. For the Chang'e 3 and the Chang'e 4 mission, you know that the moon is a very large celestial body, and the orbiting speed is about 1,060 meters per second. So landing on the moon need a very large scale propulsion system and sling down the spacecraft and land on the surface, which have a very large rapid speed. So you see there is a the distance between the Earth and the moon is more than 380,000 kilometers. So there is a delay between the telemetry, the data link. So the spacecraft should be highly autonomous. So we master this soft landing technology. You see these 3 missions made a very good base for this Chang'e 5 mission. And also we have another particular mission called the Chang'e 5T1. With this mission, we master the technology for re-entry capital to return from the moon to the Earth with the speed approaching the second cosmic velocity, and also the technology of skip re-entry. So this is also very particular in our plans, because we need to land on the Inner Mongolia. Which is necessary to use the skip re-entry. So you see these projects before are very important for this Chang'e 5 mission.
It is a very gradual process, isn't it? With baby steps achieved each way. We've gone from orbiting to landing and now to returning, if all goes well. Mr. Xu, what do you think of these achievements in the past 16 years?
Well, I was there at the beginning when we were drafting this plan of orbiting, landing and sample return. This is certainly a technological demonstration of the capacities and capabilities we have. And now after the successful orbiting and landing, we have been very innovative because the orbiting, the Chang'e 1 and Chang'e 2 are in fact redundancy programs. The Chang'e 2 is redundancy for Chang'e 1. And Chang'e 4 is a backup of Chang'e 3. So once we achieve the success of the first mission, the second mission has always been very innovative and creative. The Chang'e 2 has been diverted to a celestial body that is very far away from Earth, which is the most distance that we travel by a space object, a spacecraft. The Chang'e 4 has been landing on the far side of the moon, which is unprecedented in the Earth, based on the success of Chang'e 3. So Chang'e 5 is, with a sample return mission, will also be very creative and also has not been achieved in the past 44 years. So the last sample was returned in 1976 by this former Soviet Union. So we're expecting a success of Chang'e 5 and also looking forward to more innovative ideas of Chang'e 6 mission, which could be on the polar region or could be a very open project for international cooperation.
It is a very creative project mission, as you mentioned, but one that's with many, many challenges to come. Bear with me here on our program. We'll be coming back and talk about the challenges also later on. And China's aerospace industry is a hotbed for young talent. In particular, a growing number of female engineers are playing an increasingly important role in the missions. CGTN's Wu Lei met with a female assistant engineer who participated in the Chang'e 5 lunar mission at the Wenchang spacecraft launch site. Here is her story.
它是一个很复杂的任务，而且它带有了嫦娥奔月这种古代神话一样的浪漫色彩。之前总觉得这一类的工作都是特别高端、特别高大上，但是我们想象中的这些其实都是由这些很基础的工作构成的。我叫崔一涵，今年23岁，我在这边工作已经有3年了，差不多一直都是在从事指挥显示的工作，把发射场各种数据信息转发到需要使用这些数据的地方。
何总，你看，我们刚刚听到了一系列的口令哈，而且提到了很多的地名。你看厦门、 铜鼓岭、西昌，能不能给我们解释一下这些地名为什么刚刚会被频繁的提及？
它这些地方主要是因为马上就临近发射窗口了，就是因为各个地方它这个在这个火箭这个飞行过程当中，它要负责火箭的一些这个遥测参数的监测和这个接收，这样的话就是能够实时的，就是我们地面能看到火箭舰上的遥测的一些信息。那么这样的话，像我们的这个铜鼓岭还有厦门都是我们地面的。
我们听到前面又有口令传出。
景山、华山、陵水、厦门、165、312、311、313、321、331、341、351、361、381、391、511、521。
刚刚又提到很多的数字哈，
这样的话就是我们在执行发射任务的时候，其实好多岗位我们都是以数字作为代号的，
一个代号。
这样的话就是大家叫起来之后，一个是非常容易记忆，另外一个就是口令也比较清楚。
那刚刚我们看到这个发出这个口令的应该是谁呢？
应该是，我们现场发出口令的是我们的动幺的指挥员，这个背景的应该是有通波的这个有打通波的人员，他在这个协调调度各方面的人员。
我们每次火箭发射任务的时候，都会特别关注这个动幺
现场的动幺，因为现场动幺主要是负责舰上的各个系统和飞行器它的状态的协调。
对，
那个后面越到窗口临近之后，所有的关注点都会集中到现场的动幺的这个。
厦门讲。
之前我们关注到历次的发射，动幺指挥员，尤其是倒计时的时候哈，都是一定要口令非常清晰，非常洪亮，
非常清晰，非常干脆，非常利落。
对，
这样的话，一个是让各个系统提高注意力，另外一个就是让各个系统能够清晰地听到这个指令。
391讲。
现在现场不时的有最新的口令声发出，其实也是，我觉得也是在提示我们，今天我们从画面当中能够看到的，是在前方，文昌航天发射场的工作人员、科研人员。但是其实
看不到的还有好多地面的一些，发射支持，包括我们的测量的一些数据的接收、地面的保障、后勤保障相关的人员。
没错。你看我们现在双视窗的画面当中啊，一边是整个长征5号火箭的状态，
对
啊，不时的有这个，
我是文昌，
因为是注加燃料哈。
对，它一个是这个我们看到左面的这个应该是这个火箭整体的这个一个概况，右面的话我们会达到一些局部的一些关注的部位和关注的下面进行了关键的一些环节。刚才看到的就是舰地的一个连接器，这个连接器后面可能会脱落，这样的话就是现在还处于一个连接状态，所以大家就是给了它一个特写。
对。这个连接器大概是到负多少时间的时候可能会就完全的脱落掉呢？
舰上的连接器它的脱落时间不完全一致，有的早一些，有的晚一些。像我们的空调连接器脱落的相对来说时间就比较早，因为今天本来天气也很好，
对，
脱落之后呢，就是对有效载荷的温湿度保证是没有任何问题的。有些连接器脱落的比较晚，像我们的这个液氧的加注的那个连接器，一般的都是负3分钟左右的脱落。而有些是属于这个像液氢的加泄连接器，这些是火箭不起飞它是不脱落的，就是为了保证就是如果出现紧急情况，我推进剂还能随时的泄出，这样的话有些我们叫0秒，就是火箭起飞之后，然后这个连接器才随着火箭飞行它才自动脱落，
对，
只要火箭在原地不动它是不会脱落的。
对。我们其实现在从画面当中也能够看到，第一是现在的天气情况还是非常良好的，
对
啊，包括我们之前可能还有担心，万一今天有这种弱降水情况哈，会不会对发射窗口带来一些影响？但是现在看来，天气很晴朗。
其实天气对火箭发射来说影响还是非常大的。
对，
火箭因为是低温火箭在这个发射阶段呢，主要还是怕这个降雨。如果是这个降雨比较大的话，会影响舰上的一些产品，特别是电气产品，它的这个它如果是有这个雨水进入之后， 不影响它的这个电气系统的状态。另外一个，如果发生降雨的话，一般都伴随着比较厚的积云。这样的话，如果是火箭穿越这个积云状态的时候，可能会引发静电放电。
对，
静电放电的话，会对舰体产生一个非常大的一个这个从电的方面来说是不利的影响。在国际上也出现过，由于这个火箭飞行诱发雷电造成失利的这种情况。
所以其实尤其是从这个现场的情况来说，有时候可能您刚刚提到的雷电天气可能比降雨天气对火箭的发射影响更大。所以我们能够看到画面当中啊，周边有几个这个塔架。
对，那几个塔架是保证火箭转到这个发射区之后，它的安全的。
对，
它是发射区的一个避雷针。
避雷塔。
对，避雷塔。对，它的作用就是这个，如果这个火箭转到发射区之后，如果出现比较厚的这个积雨云，它通过这个咱们的这个避雷塔，把这个电流引到这个引到咱们这个大地里去了，保护咱们的这个火箭。
我们现在也能够看到双视窗另外的画面当中提示我们啊，离点火的倒计时，已经不到25分钟了，可以说时间越来越近了。再过一会儿呢，长征5号火箭就将带着嫦娥5号探测器点火升空。我们再来了解一下嫦娥5号任务呢，是中国探月工程绕落回3步走的收官之作。我们可以跟大家来简单的梳理一下，第一步绕月的顺利完成呢，是在2007年，我国第一颗月球探测卫星嫦娥1号发射升空。在13天之后呢，进入月球环绕轨道展开科学探测，并成功获取了全月球影像图。而在2013年的12月，嫦娥3号的成功落月，实现了中国航天器首次地外天体的软着陆。此后，在2019年的1月，嫦娥4号成功登陆月球背面，首次实现了月球背面的软着陆。那么，即将开启探测的嫦娥5号任务呢，也就是承担着探月工程3步走绕落回中的回，也是首次进行地外天体采样返回任务。嫦娥5号任务呢，是一共会持续20多天的时间，任务的时间比较长，看点也是非常的多。我们跟大家总结一下啊，有一发一落一采一升一会一回。期间呢，还涉及到探测器的4个组成部分，也就是上升器、着陆器、返回器、轨道器的多次分离组合。那接下来我们就一起来梳理一下嫦娥5号的任务流程。
一发嫦娥5号发射任务是在中国文昌航天发射场进行，由长征5号遥5运载火箭将嫦娥5号探测器送入地月转移轨道。一落，嫦娥5号抵达环月轨道后，由着陆器和上升器组成的着上组合体与由轨道器和返回器组成的轨返组合体分离，并降落在月球正面风暴洋北部。一采，着上组合体在月面通过钻取和表取2种采样方式，采集约2公斤月表岩石和土壤样品，同时开展科学探测。一升，完成采样和封装后，就进入月面上升段，上升器将以着陆器为基座，从月面起飞。一会，上升器到达环月轨道后，将与轨返组合体进行月球轨道交会对接，并将样品转移到返回器内。一回，轨返组合体与上升器分离后飞返地球，途中返回器还将与轨道器分离，并通过半弹道跳跃式再入的方式返回并着陆。
好的，刚才我们和大家介绍到了片子梳理了嫦娥5号的任务流程。那现在我们再把视线赶紧到前方，我们来关注长征5号火箭的发射状态。我们刚刚好像听到前方啊，因为娄总其实从-30分钟开始以后，对。前方就不时的会有各种的口令声传出来。
对，这个口令会随着窗口的临近越来越密集，主要是它协调各个系统之间的这个动作，保证最后的点大家齐步走到一个时刻的。
全区各号30分钟准备完毕。文昌报告完毕。
我们也听到前方
大家看到的这个现在看到的火箭的这个火箭的整流罩，
对，
整流罩里面就是安坐着我们这个嫦娥5号的探测器。
对。所以您刚刚也提到了，这次嫦娥5号整个的载荷它的重量哈，
1号
重量达到了8.2吨。
全区各号30分钟准备完毕，请示由动幺下达15分钟准备及后续口令。文昌明白。
后面的口令就由现场来下达了，就是，就是我们后面再听到口令，就全部是由那个指挥大厅发出来的了，就。
通过令。
而且越到后面哈，可能这个动幺要发出的口令就越来越多了，
越来越多，越来越密集，对。
我个人其实之前也是2次到文昌航天发射场参与过现场的这个航天发射的报道任务啊。每次到文昌的时候，感觉那个地方的整个的航天的这种气氛也非常好，
航天的氛围非常好。
对，
因为我们这个文昌它是我们国家新的这个航天城。
文昌动幺报告，我是文昌动幺，请讲。阵地30分钟，准备好。文昌明白。
阵地30分钟准备好，
对。
我们之前刚刚好像看到画面当中还有一个可能是摆杆还是一个部件脱落掉了啊。
刚才
是一个
看到的有一个特写的一个镜头，那么这个特写的镜头应该按照这个流程应该是整流罩的这个空调送风的这个连接器脱落。因为我们的这个整流罩这个里面呢是有效载荷，它有效载荷对里面的温湿度要求还是比较严格的。为了保证有效载荷的各个器件在里面这个工作出一个比较稳定的状态，那么这样有一个温度和湿度的相关的一个要求。那么这样的话，地面有一个空调送风系统，这个送到整流罩里面，确保我们这个有效载荷整个在测试期间它的温度和湿度在一定的温度范围之内。因为马上就面临发射了，所以说这个在这后面的一段时间内，我们这个应该里面的这个温湿度应该是没有问题的。所以说这个时候为了简化射前的这个
around the moon and will be the way of getting to the surface of the moon. So we'll be sending astronauts there to the gateway to do science. We also have robotic missions which will be going to enable communications, navigation and transportation to the gateway and to the surface of the moon. And we're also working on science and technology which will help us extract, for example, water, oxygen and metals from the surface of the moon, resources in situ which we can use then to support a future human base, for example.
Mr. Makorian, I was talking with my guests here in our studio who said that in the future lunar probes, in Chang'e missions in the future, there could be more international cooperation. Would Europe be interested in working with China, not just with the lunar probes, the Chang'e missions, but also in other aspects of space exploration?
Well, that's a very good question. And in fact, we already have collaborations with China from the European Space Agency. Some of our astronauts have traveled to train with Chinese astronauts, and there's the possibility of European astronauts perhaps flying to the next Chinese space station. We're involved in collaborations on Earth observation, looking down at resources on the planet Earth. And currently, for science, we're building a new satellite to investigate what we call the magnetosphere, the near-Earth environment where the particles from the sun hit the magnetic field of the Earth. That's a joint mission between China and ESA called SMILE. And of course, we're very interested in the south pole of the moon, as many people are, perhaps a destination for Chang'e 6, because that's where ice may live still today, unaffected by sunlight, hiding in the dark craters at the south pole of the moon. And of course, that would be vital for a future human base. So we're already working with China and certainly very interested in exploring new opportunities.
And we look forward to more cooperation in the future. That's Mark Makorian, Senior Advisor for Science and Exploration at the European Space Agency. We thank you so much for making time for us today. And let's head back to my guests here in the studio. You know, we talked about past achievements in China's lunar probe, and now we want to focus on this Chang'e 5 mission in particular. This will be, as many analysts have pointed out, the most complex of the Chang'e mission so far. Professor Yang, in what way will this mission be particularly complex?
In the previous introduction, it already mentioned the Lunar 24 mission, which is the last sample return from the moon since 1976. So you see that the former Soviet Union has performed 3 successful sample return missions, Lunar 16, Lunar 20.
1 second, Professor Yang. We're hearing from the Command and Control Center that 15 minutes until launch. We're hearing instructions coming from the Command and Control Center that we're now 15 minutes from the launch of the rocket. Please continue.
Well, these 3 missions brings about more than 300 grams of samples from the moon. So you see, these missions choose a relatively simple method. The probe directly ascend from the lunar surface and directly come back to the Earth. So that is the reason it only brings so little samples to the Earth. So this time, to bring more samples to the Earth, we choose a different method. Lunar orbit rendezvous. So you see, because the re-entry capsule needs some heating shield to protect it from the high friction, the heat from the friction with the atmosphere. So these kind of measures are not necessary for the sampling on the lunar surface. Well, on the lunar surface, there are different considerations. So the spacecraft of the re-entry capsule and the ascender are quite different. We choose a lunar orbit rendezvous, which is much complex than the former Soviet missions, and this is very similar to the Apollo programs. You can recognize the lander and the ascender as the descent pad and the ascending pad of the lunar module of the Apollo spaceship. You can recognize that the orbiter as the service module of the Apollo spaceship, and the returner or the re-entry capsule as the command module of the Apollo program. So this mission, although it is an unmanned mission, but the configuration and the mission profile is quite similar to the Apollo program, very complex. And to my understanding, the most challenging part will be the lunar orbit rendezvous. As the previous introduction, it will be the first unmanned lunar orbit rendezvous and docking. No one has done this before. It is quite challenging, and because you see, to rendezvous and docking near the Earth, we have all kinds of support. We can have ground stations, we have data relay satellites, and we have the GNSS or the navigation satellite system to support these kind of missions. But for the docking and rendezvous near the moon, we don't have so much support. We only mainly depends on the spacecraft itself and limited support from the ground. So this is also very complex and really tough. This is with very high risk. So you see, this program is very, very complex, but we have advantage. We can have more samples. As introduced, we can have 2 kilograms of samples potentially, which will be more greater than the total sum of the samples get by the former Soviet Union 3 missions. So you see, with this mission, we will master many new technologies, and will be a good preparation for the potential future manned missions to the moon.
We're all very excited about this mission, and precisely because of all of those firsts that China is endeavoring to achieve, of all of those challenges, and much of the attention from people here in China and abroad will be focused on how China will rise up to the challenge. Mr. Xu, your take on what will people be looking out for in this mission, and what will be the biggest potential challenges as we move forward?
Well, I think this is a clear demonstration of technologies for preparation of human missions. In the world, we do have 2 different mentalities. One is for robotic missions to explore outer space. Another intention is to humanly explore outer space. We saw just now the programs of Artemis, or the Gateway, the US has called it. The concept is to build a lunar space station where it will orbit the moon, and then they will have multiple missions of sample return to the Gateway, and then the samples will be selected and filtered by human missions, and then human mission will bring the samples back to the Earth. That is the configuration of the Gateway. And what we're doing is to demonstrate the capability of going back to the moon, bring samples back to Earth, and these samples can be replaced by human, so that in the future we can enlarge or blow up this model and achieve a human mission. So this is something that we could look forward to in this Chang'e 5 mission.
Let's briefly talk about the whole process here, because that will be important for our viewers to understand. We're also hearing from the ground command center that it's now 10 minutes away from the launch. We're keeping a close watch on that as well. So in a nutshell, we'll be bringing in soil and rock samples from the moon. How do we do that? So this probe, the spacecraft, will be made up of 4 components. There will be a lander, there will be an ascender, there will be a service module or an orbiter that will be waiting for the ascender after it collects the samples, and then that return capsule that basically hauls back everything it collects from the moon and return to Earth. In terms of these 4 components and the steps connecting each of them, what do we know about potential risks? What do we know about where it could go well, where it could go wrong, because we haven't done that before? This will be the very first time, Professor.
Well, in fact, every procedure in this mission will be very challenging and risky, although we've already done that before. For instance, the Long March 5 need to send the spacecraft to the Earth-Moon transfer orbit. During this process, we need 2 to 3 mid-course correction, because you see the accuracy of the rockets is not enough for the spacecraft. The orbit insertion near the moon will be very critical, so we need a mid-course correction by a very accurate measure of the orbit, and then do this. And the orbit insertion is also very challenging, although all the 4 missions have done that before. But still, because we need a large velocity increment in this lunar orbit insertion, so it is also very challenging. And lowering down the orbit to the moon, and then the separation between the 4 parts. As I mentioned, the descent, the lander, and the ascender, and the lunar module. So the separation is also a very critical point for this mission. And the landing on the moon, you see, always be very, very dangerous. And Israel and India has just suffered failure not very long ago. So sampling on the moon is also very difficult, because you see the lunar surface, the environment is very crucial. The temperature is very high under the sunshine, is very low under in the shadows. We must consider, and also consider, the influence of the dust on the moon to the spacecraft. And the sampling, as we see, we need to drill 2 meters under the ground, and also we have a scoop to scoop up the reckless to the spacecraft. And the ascender, the package, is also very, very important, because any leakage could cause the loss of the samples. So the package must have a very complete sealing and be done properly. And ascending itself is also very challenging. You see, we never done this before to lift off from another celestial body. The problem is that because there are always errors, so the coordinate of the landing site, we don't know that, because we need to measure that after landing, and only after this we can have the coordinate of the where we lift off, and also the angles of the slope also have influence to this procedure. So all kind of influences as factors, we must consider that carefully for this lift off. And also, as I mentioned, the rendezvous itself is near the cislunar space is the most difficult part, from my point of view. And also the return itself is quite difficult.
Although we're witnessing the rocket launch today, what will be more challenging will be what happens on the moon after that lander makes itself on that moon. And all of this will have to happen in the time frame of 1 lunar day. That's 14 days on Earth. Do we have to worry about that time frame to get all of this accomplished, Mr. Xu?
Well, I think timing is very important in this mission. We also, Professor Yang has just mentioned, there are many challenges in the details, in the landing and the ascending. This particular mission is different from Chang'e 3 and Chang'e 4 landing mission, because this has an ascender which has a higher center of gravity, which means it might be tumbling if the surface is not flat. So the autonomous terrain selection system and validation system is very important. So once, as you mentioned, the timing of this mission, you have to validate the landing site by the spacecraft itself during its orbiting to the lunar surface, and then make a final decision on the landing site. There are 3 or 4 landing sites that can be chosen from, and then you will have this landing once it's successful on the flat base, you will have another challenge of ascending these samples and rendezvous to the return capsule and the orbiter. So all of these are done without human interference, without navigation systems, without any assistance on the ground. So these are very challenging and very time demanding and precision demanding mission.
It looks like we're less than 5 minutes away from the launch of that rocket. We'll take you to the Wenchang launch site as that happens, so make sure you keep it with us right here on CGTN. Let's talk about the part where the lander is responsible for for the digging and for the collecting and the sampling. It will do so with robotic arms. Is that process fully automated? Is there any interference from, let's say, humans on Earth for that process?
There are two instruments that we brought to the lander. One is the visible and near infrared camera that can help, as Professor Yang mentioned, the scooping of samples on the lunar surface. Another one is a radar, a penetrating radar that can penetrate the ground, that can tell the character of the ground and the hardness and the softness of the ground, so that the drill can drill 2 meters into the ground and bring samples back. So there are two different methods of collecting samples at the same time. We do bring these two instruments on board. We might analyze on the ground by these parameters and informations prior, during, and after the drill.
All right, it looks like we're just moments away from the launch of that rocket. This is a Long March 5 rocket. We're now 3 minutes away from the launch here. When we talk about what's going to happen on the moon later in this mission, people say that the docking and the rendezvous, as Professor Yang mentioned, is extremely difficult. Help us understand how that process will happen and what should we look out for?
Well, for lunar orbit rendezvous and docking, first you should have a very accurate measurement. So you see we have all kinds of instruments such as docking and rendezvous radar, which is, you can recognize that as a derivative from the docking and rendezvous radar of the Chang'e spaceship, but it is a much smaller version. Also, it has a new function to have vehicle-to-vehicle communication, which can exchange data. So you see, this instrument is very critical for our lunar orbit rendezvous and docking. One side from the ascender and one side from the orbiter. With this instrument, we can help the two spacecraft to measure the distance from each other and also measure the angles. And then from the final step, the two spacecraft should docking autonomously with the docking mechanism, which is quite different from the mechanism we used by the Chang'e spaceship and our space station. Or from the front, we can hear that it's 2 minutes counting down, T-minus 2 minutes counting down, and I believe that the spacecraft has changed the power.
现在唯一看到的一个是那个和火箭连的是一个轻的一个紧急排气的一个紧急排气。如果说火箭点火过程当中出现问题，不能正常起飞，那么这个连接器它其实是不脱落的。不脱落的话，这样的话就是氢箱如果蒸发的话，可以通过这个连接器把这个氢气排走，这样的话就不至于对这个建筑周围排氢气造成安全隐患。
1分钟准备。
1分钟准备了。我刚刚看到长5的这个特写画面啊，也是能够近距离看到长5这型火箭非常漂亮，
非常漂亮。因为这个火箭整个的它的这个整流罩的气动外形和我们这个助推器的这个外形，
我们刚刚听到50秒，我们现在把时间完全交给现场。
好
，40秒。
我们来聆听指挥员的每一次口令。
30秒，30秒。20秒，明白。10秒，9、8、7、6、5、4、3、2、1，点火，点火。
大家看到发射台的喷水， 这样的话喷出来大量的水之后，其实对发射台是一个保护的作用，因为火箭的这个尾焰的温度非常高，如果不保护的话，这个
起飞时间纵4时3纵分2幺秒，8纵6毫秒。
这个火箭这个起飞过程非常非常的
对。
因为是在夜间发射，所以说这个地面光学看的效果就跟上一发可能相比就不如上一发好。
跟踪正常。
但是非常耀眼。
但是非常耀眼，对，我们能看到这个发动机喷出来的这个尾焰，这个。
文昌光学雷达跟踪正常，遥测信号正常，文昌飞行正常。
对，现在一系列的正常的指令声发出来。
对，大家在这个这里应该是穿越云层了，
云层了。
大家在这个观看过程当中呢，就是可以注意到这个火箭的这个尾部的这个火焰，因为这个尾部的火焰，这个从喷管喷出来之后，它是受周围大气的影响。刚才大家看到的这个火焰应该是比较亮的。
Tracking of the predetermined orbits and the speed and altitude, so to keep track on the normality of this rocket.
And we should also notice that the rocket is not flying straight up; it's going sideways. There's a little turn.
It's called pitch over.
Pitch over.
Yes. So the first critical step will be after the tower is cleared will be the pitch over to the so we call the launch direction. With this direction, we can determine the orbital plane. And from you see, this is a video from the camera mounted on the rocket itself on the core stage. We can see 2 of the 4 boosters. Well, the 4 boosters provided 90% of the thrust during the liftoff. So on this stage, mainly the thrust is from the 4 boosters. And after pitch over, the next critical step will be the separation of these 4 boosters.
Yes.
Yes. Exactly.
And we keep hearing that the monitoring and command center reporting how the flight is going to continue. They're going to continue to track the flight of this rocket, and then a few minutes into its flight, we'll see the boosters come off the rocket, and you're looking at the pictures being captured by a camera just attached to the body of that rocket, showing, as Professor Yang mentioned, 2 of the boosters there. There are a total of 4 boosters on the body of the rocket. They will all come off later in the flight and allow the separation of the first and second stage rockets.
So each of the booster has 2 engines, so total of 8 engines on the booster, and also engines on the core stage. So the boosters are composed by liquid kerosene, liquid oxygen rocket engine, but the core is cryogenic, which is liquid oxygen and liquid hydrogen.
Help us understand the choice of fuel here.
Well, the liquid kerosene, liquid oxygen works very well in the atmosphere, where the liquid oxygen and liquid hydrogen works better in outer space, which has better propellant propulsion rates.
Okay, the boosters
and
have
the
been
boosters
separated very
are
properly.
being separated. They come off to, because they burn out the fuel. They have to come up to allow the rocket to continue flying.
So now we see the core engine is burning, which is the liquid oxygen and liquid hydrogen.
So at this stage of the flight, what the rocket is doing is that it's accelerating in terms of speed, and until it reaches that height, it will continue to increase velocity.
Yes, it was increasing velocity and altitude at the same time.
From this 3D animation, we can see the data link from the vehicle to different ground stations. We have ground stations at the launch center, and also have the stations in the Xisha Islands, and also at every critical point, for instance, before the spacecraft separation from the rocket, we also have the ground have space tracking ships in the Pacific Ocean.
The number we see on the screen is the number of seconds into the flight. So we're now more than 4 minutes into the flight.
At the current stage, the core stage work with the what's so-called the YF-77 rocket engines. We use 2 engines in this core stage of the Long March 5. Each have a thrust about 50 tons. So this rocket engine is the largest, as Mr. Xu has mentioned, the liquid hydrogen and the liquid oxygen engine, which has the highest specific impulse in China's rocket engine families.
And the next noticeable development would be the separation of the first stage and second stage rockets. How long till we have that? A couple of minutes?
流水3901跟踪正常。
This is a camera video from the inside the payload fairing.
The camera seems to be working very well.
The payload fairing is jettisoned.
Okay, the fairings.
雷达跟踪正常，遥测信号正常，文昌飞行正常。
The fairings are at the very top of the rocket. They protect the spacecraft, basically.
Yes, once it's out of outer space, once it's out of the atmosphere. It doesn't create any frictions. So we have to lose weight as well as the boosters.
Absolutely.
We drop all of them to increase the propulsion ratio so that we can have better propulsion for speed and
Absolutely. So are we now out of the Earth's atmosphere?
Yes, we are out of. I think it's more than 100 kilometers above Earth.
The atmosphere is about 70 kilometers.
Yes, about 70 to 110. Yes.
Okay.
From the voice, we can hear that the telemetry data received from the Xisha Islands, the ground station located on the Xisha Islands, received the data, and it shows that the data works properly.
2521遥测信号正常。
So normally there are two different kinds of observations. One is telemetry tracking, another is optical observations. So once it's above the optical observation capabilities, we'll rely on the TTNC, telemetry tracking control command.
As Mr. Xu mentioned, we have optical telescopes to observe the flying, and also we have ground-based readers to measure the trajectory of the rocket.
And that's what we've been hearing.
西沙3113跟踪正常。
Yeah, just now as we've been hearing, those are personnel on the ground, some on the ground, some in Xisha Islands, to keep tracking the flight of the rocket.
The voice mentioned the 313 is the trajectory tracking radar we use in every mission from the Wenchang Satellite Launch Center.
Understood. So now this will be actually a longer phase in that flight. You know, we've had the boosters come off, we've had the fairings come off, we've had.
But this is still the critical moment because the core engine has experienced a couple of times of failure in the past 4 missions. So we have to make sure that we witness the separation of the first stage with the second stage, and the core engine burns properly so that we can ensure the success.
The first stage use, as Mr. Xu mentioned, the cryogenic propulsion system with liquid oxygen as the fuel and the liquid hydrogen as the fuel and liquid oxygen as the oxidizer. It has a very high specific impulse, so this with little consumption of fuels, it can provide much more.
Now the first stage and the second stage.
Great.
Rockets are being separated. We're hearing applause from the control and command center. Everything seems to be working just fine.
So the second stage we use the YF-75D rocket engines, which also use the liquid hydrogen and the liquid oxygen as a propellant. The thrust is smaller, but the specific impulse is even higher than the first stage.
And later in the flight, that engine on the second stage rocket will be shut for a while when the rocket is cruising.
Yeah.
And there will be a second ignition later in the flight.
Exactly.
Is that correct?
So you can see from the 3D animation, we have data links from the from the ocean surface to the I believe that is a ground space tracking ship, and to the vehicle. And also, as you mentioned, after this spacecraft, the rocket enters what we call so-called the parking orbit. The rocket engine will be shut down, and we will have a coasting phase with no propulsions, and we will have the second ignition near the equator to have the lunar orbit from the low Earth orbit to the lunar transfer orbit. Now we can see the videos mounted from the camera mounted on the rocket, and also this is camera mounted near the rocket engine, we can monitor the working of the YF-75D.
You can see the flame coming down from the underpart, which is the burning of the engine.
And it says second stage engine right there on the upper right corner of your screen, indicating what this camera is showing us. And these cameras do seem to work extremely well in outer space.
And you see that because videos always have a very large amount of data, so the transfer rate from the spacecraft, from the rocket to the ground station, has a very high data transfer rate. So this is a very high requirement.
And how long is this process, until the engine shuts off for that brief period until it hits a second ignition?
It normally takes a few minutes.
A few minutes.
Yeah. So it very much depends on the orbit that you are planning. So this is a translunar orbit. So it depends on different missions. So the timings are different.
So we're basically waiting for when the rocket and the spacecraft eventually hits that translunar orbit.
Yeah. We will have a number of maneuvers before it takes off to the lunar orbit, translunar orbit. And then during that course, we will have a number of corrections, and depends on the precision of the insertion of the spacecraft to that orbit.
What type of maneuvers?
It's like Professor Yang mentioned that once we're leaving the Earth orbit, we'll accelerate to the lunar orbit, and once we reach the lunar vicinities, we have to slow down, what we call a brake, to insert into lunar orbit, so that and also we will descend gradually from a higher altitude, like 300 or 400 kilometers, to eventually less than 100 kilometers, so that we can prepare for the descent of the ascender and the sample return mission.
Well, you see from the camera mounted on the rocket, we can see that the rocket itself is already under the sunshine. Although we in Beijing here is still at night. Great. The first shutdown of the rocket engine on the second stage. So now we are in the coasting phase.
Coasting phase.
Yeah. So it's already in low Earth orbit with altitude of about near 200 kilometers. We will fly to, as I mentioned, fly to a place near the equator and then ignite again.
Help us understand a little bit more about this process. When the engine has shut down and the rocket is coasting, what's happening now in this process?
So first we need to know that because we choose this kind of procedure because of the location of our launch site, because we don't have a launch site at the equator or near the equator, so we need this coasting phase to adjust its orbit. So the orbit is determined by the points where the engine is shutting down. So we need to have an orbit with the apogee near the equator. So we only have this choice to have a coasting phase and then ignite again, and finally it can enter in orbit with the apogee near the equator. So that's the necessity of this kind of to enter the Earth-Moon transfer orbit.
Mr. Xu, at what point do we know we can reignite again? What are we waiting to see happen?
Well, probably you can see from the telemetry and tracking control ship that they will. It is near the equator. As you mentioned, the launch site is also near the equator. So we're adjusting the spacecraft to the equator, the Earth equator, so it can reach at the apogee point, as Professor Yang mentioned, and then we fire to adjust so that it will be in the flat face of the equator, and then increase the speed so that it can goes to the perigee, where it can have a longer and more higher velocity compared to the current one. So as we call it, sling off by the Earth's gravity to the lunar orbit.
Usually we also call this second burn of the engines a perigee kick. A parity kick can be achieved by the second burn of the end stage, and can also be done by a separate rocket engine. Usually, for instance, during the years before, when the space shuttle launched a deep space probe, usually it uses this kind of parity kick engine. It will be a very small, solid rocket motor. Well, because we know that for the Long March 5 series and of Long March 3A series, we have the capability of the second ignition. So we don't need this kind of separate motors. We only need the engines to shut down first and then ignite again.
So as we call it, to escape from the Earth gravity. The Earth orbiting satellites have a lower velocity, where compared to this mission, you go to the moon, you have to escape the Earth gravity. So we need to fire multiple times in apogee and perigee, and to sling off the spacecraft to the lunar orbit.
During this coasting phase, although the YF-75D engine is not working, but we still need to control the attitude of the spacecraft because we need the correct orientation of the antennas to send the data to the ground and also to prepare for the second ignition.
How do we do that? How do we maintain?
We use some other thrusters, some kind of small thrusters, because you know that at this altitude there will be no atmosphere, so we cannot use other measures. We can only use the rocket thrusters, but much smaller than the, as I mentioned, the main engines. So we use these thrusters to keep the attitude of the spacecraft and also the orientation of the antennas. But still, now we have the link from the rocket to the Tianlian data relay satellite.
This is a rather long process that will likely take a few more minutes until we see that second ignition again.
You see, now we can only see the 3D animation. This is because, as I mentioned, the videos, transferring the videos need to transfer a large amount of data. So only a ground station can do that usually. For a rocket, usually we don't have this high gain antenna to transfer videos. So you see, in some phases there is only critical data transferred, so there is no video.
We're also looking at the flight time to the left of your screen. 1,038 seconds into the flight now.
So the second ignition is approaching.
The second ignition is approaching. This is what we call a coasting phase. It takes a few more minutes until we can see that second ignition happen.
So the second ignition is also a very critical step for this launch, and only a few countries can do this. If your end stage have the capability of the second burning, you can do a lot of work, such as the launching an object into a high elliptical orbit, which is very useful in deep space missions.
You know, let's leave it for now, because this will take another few minutes until we see that second ignition happen. I want to continue to talk to you about what will happen on the moon. When will we see the deployment of the lander on the moon?
Well, as Mr. Xu has mentioned, we have some instruments on board the lander, because you see, we need to choose the samples, and the samples must be collected properly. So we have a lunar penetrating radar which will measure the structure under the ground, and we can choose the right place, because you see, we not only need to have a drill deep under the ground, 2 meters, and also we need to know other references of this. But we must have done this within 14 days, because as we have discussed, the design of this spacecraft can only work in the daytime of the moon, and cannot work or cannot survive during the lunar night, which have very extremely cold environment. So we must do this with limited time, and also the scope we also must be designed very carefully. You have asked the question about it is automated or controlled by the ground. So we do have the data link between the ground and the lander, but you see that because the different distance between the Earth and the Moon is about 380,000 kilometers. So there is a time delay. So for any actions on the lunar surface, we must consider this influence. And also the operations of the robotic arm, the scoop, and also the drilling, we must consider this. And also another challenge is the packing of these samples. We have the rocket course and 2 meters under the surface, and also have the reckless. We also need to consider the influence of the flames of the rocket engines of the lander, because this also will have influence to the samples.
Will we be able to see that process as it happens?
Well, I think there are a number of cameras that has been mounted on the spacecraft and the descender. I'm sure we will see some of the images. The collecting process might not be easily visible, but the descending and the ascending process we will see quite clearly, as we experienced that from the Long March 3 and 4. The Chang'e 3 and 4 missions, which has descended to the lunar surface and the rovers itself. So we do have cameras that is working very well, but as Professor Yang mentioned, the cameras and the images take a lot of bandwidth, take a lot of capacities of the telemetry and tracking system. So from the lunar surface to the ground will take some time to process, but I'm sure we will see some of the images.
The tasks ahead on the Moon, including the drilling, the sampling, the collecting, do we know how time is planned? Do we plan everything down to the last detail, or do we allocate this period of time for each task?
Well, this depends on the plans by the team itself. You see that there are multiple choices, and also after landing, as I mentioned, there are also many other important and critical tasks. We need to measure the accurate coordinates of the lander to prepare for the ascending procedure, and also
so this can be pre-planned in advance.
Exactly.
Everything will have to be.
So we have many multiple steps, and also as Mr. Xu mentioned, we have some instruments such as a panoramic camera. With this camera, we can see the images from the lunar surface and check the situation of the lander itself and choose where to get the samples. So this kind of operations can be designed after the landing procedure and then determined by the commander on the ground control.
Let's talk about, as you mentioned, samples. Let's talk about why we need these samples. By studying these samples, scientists say that we can better understand the volcanic activities on the Moon and the age of the Moon, maybe. So, Mr. Xu, how are we going to work with those samples that we make painstaking efforts to collect?
Well, these samples, first of all, have with the COVID-19, the word quarantine, but in our space sector, we also have what we call interplanetary quarantine. So this sample has to be properly sealed to make sure that it doesn't have interplanetary infections, like with what we call aliens, maybe some other germs,
like what you see in movies.
Yes.
Like you can.
So these has to be very carefully handled, especially sample return missions. Secondly, is that the samples, once returned to the Moon, to the Earth, we will have scientific communities to study very carefully. This will be beneficiary in a number of areas, including chemical areas, including mineralogical, petrological, isotopic, and geological. So there are many domains that we can study the samples and tell a lot of stories from the lunar surface and in connection to the development of Earth and in the universe as well.
When the samples are brought back to Earth, will it only be China studying them? Could it be shared with other countries?
Obviously, it will be shared by other countries. There are examples before. You see that during the end of 1970s, the U.S. gave 1 gram of the lunar soils as gift to our country. So we have some, we studied these kind of samples and have some articles published on very important, very influential scientific journals. And also, there are examples that the former Soviet Union and the United States exchanged their samples. You see that although the Apollo program bring back about 881.7 kilograms of samples, but these samples are from 6 different locations of the moon. And the former Soviet Union gets samples from 3 different locations other than the United States. So they exchange their samples and they get more meaningful scientific research results. So this time I believe we will get our samples, and no one has get samples from this we call the Mount Rumker, which is at the northwest edge of the Ocean of South, which is the largest lunar mare.
This is an unexplored region.
Exactly. So, so this region it's relatively young. You see that other samples from Moon have a history of 3 to 4 billion years, while this region is only about a history of 1 billion years. Yeah, 1 to 2 billion years. So I believe these samples will change our view to the Moon, especially to the history and evolution of the Moon. And with this study, we can have a better understanding of all the hypotheses about the formation of the Moon, and also together with the history of the Earth-Moon system.
You know, when it comes to cooperation between countries in terms of its, their respective space exploration programs, some say, this is just about competition. You're going to have an advantage in your space exploration, whether it's lunar or other celestial bodies. How do we understand China's space program? Is China in competition with other countries, namely the United States and Russia, or is China in a better place now to cooperate and collaborate with other countries?
Well, as we have discussed, China is a developing country. We develop our space programs according to our own needs, either an engineering goal or a scientific research goal. So we don't compete with other countries, and it's meaningless for us to compete with other countries. So for this kind of scientific research, they're always top one, because you know that for scientific research, we get to this place, and it is we to get the first to get into this place. But we, as we have discussed, we also will have exchange with other countries to have different to have the samples from different places. So these kind of activities or studies will benefit not only one country, will benefit the whole humankind. So I believe that this kind of operation will be a win-win game for all these space capable nations, and in the future it will be an inevitable trend for these kind of countries to cooperate together. I am a member from the Moon Village Association, and the only founding member of the Moon Village Association from China. And our goal is to promote the cooperation between different countries, either between the governments or between the space agencies, industries, or universities.
Mr. Xu, your take on this?
Well, I think, well, there's a European saying that competition works faster than cooperation.
We're hearing that the second ignition is taking place as we speak. Now 1600 seconds into the flight, almost 1700, the second ignition has happened.
So this second ignition of the rocket will accelerate the spacecraft from the speed of 7.8 kilometers per second to about 11 kilometers per second. So that will be the Earth-Moon transfer orbit, which will be a very high elliptical orbit.
And Mr. Xu, help us understand what we're waiting to see here after the second ignition.
So after the second ignition, we will see this increase, as Professor Yang mentioned, increase in velocity. So with the basically the spacecraft is in the equator, above the equator exactly at the moment. So we will increase the speed so that we can just reach the transfer velocity. So it can go to the lunar orbit at the appropriate, like we call it, perigee point.
It will take another few minutes until we know whether we have hit that orbit.
Yes. because the second stage uses the quadratic proportion system. It works longer. It works longer than the first stage.
It's very interesting because a lot of people watch this say that for all these efforts and for all, the challenges that we will encounter in the later stages of this mission, the samples brought back to Earth don't have immediate impact on our world today. All the things we talk about, understanding the moon, understanding how it was formed, understanding the age sort of the moon, and dating all of those volcanoes, they don't have an immediate impact on our lives, on our world now. Professor Yan, how do you say to people who are rather confused or who don't understand why we go through painstaking efforts to do that?
Well, you see, for space activities, there are direct returns and indirect returns. For instance, navigation satellites, the Earth observation satellites, the communication satellites, which have served our daily life directly, so we can understand that and feel the necessary and the importance of that. But for other scientific research missions, such as the manned space activities and the deep space missions like this Chang'e 5, most of the returns are indirect. So it is our duty, it is we, staff of the employees of the space industry, to give a connection between the public and our space field, to let the public know the importance of our activities and know the returns, the great returns from this space activity. There are examples. Analysis shows that the Apollo program, the manned lunar missions, have a return rate of more than 6 or even 11. That means that $1 invested to the Apollo program, there will be returns to the whole society more than $11. So that is only a very limited analysis. So you see that it is very necessary for us to introduce the importance to the public.
Are we looking for the returns here, multiple times returns here, or are we looking into a future that could benefit all mankind, Mr. Xu?
If you see that the number of satellites that is working above us on the Earth's orbit, we can say that you can tell the difference and the importance of space by switching off the space infrastructure for one day. Then you will see that you can't tell the weather, you can't tell where you are, the navigation shut down, your phone shut down, the communication shut down. So everything will shut down. So from these lunar missions, we'll see that this is the very first step to become for humanity to become an interplanetary species, so that we can go to other celestial bodies, even planets. This is a very first step that we take as a human being to be a spacefaring species.
Let's indulge ourselves here and expand our imagination. With this step, we're endeavoring with the moon. What could the moon do to mankind here on Earth? Because people have talked about energy, right? People have talked about possibly relocating the population to the moon one day. Just help it, when we expand our imagination, what could the moon do?
Well, moon is not the ideal place for immigration. So in the future, it is only an outpost of human being. And on the other hand, the moon have a very plenty of the helium-3. Helium-3 will be a very ideal fuel for the potential fusion power, which can solve the problem of energy supply of human being. It is said that the helium-3 on board the lunar surface, can be used by human being to supply energy for us.
Years.
Yes, for more than thousands of years. So that is a very potential utilization of the lunar resources. And also because, as we have discussed, there are water ice on the lunar surface. So in the future, we can utilize this kind of water, because you know that the moon is much smaller than the Earth. To lift off from the moon is much more simpler than the Earth. So we can use the water to make propellants. So the moon can be a potential outpost for the human being to exploration and exploitation of other celestial bodies of the solar system. So there is one choice. If we want to go to Mars, we can use the moon as our basis and produce the propellants and prepare for these kind of missions.
So you can see from this picture, is a great picture, seeing that you can see from the Earth from the spacecraft. So it was a great image from the lunar orbiter. So the Chang'e 5 is taking picture of the Earth's surface before it goes to the moon.
Yes, that is a beautiful picture of this blue planet we all call home here. And this is the second stage engine, as it says on the upper right screen.
So this is a camera mounted with the direction to the backwards of the spacecraft. So you can see the background is the blue bubble, the Earth.
And isn't the next development the deployment of the solar? Are we looking?
There will be a separation. Once it's shut down, we'll have separation of the second
It's
stage.
shutting down again. We just heard from.
Yes, we can hear the voice that the second stage is shut down.
It's
so the next step
down.
will be the separation of the spacecraft with the end stage of the rocket.
Yes, we're looking forward to seeing that separation of that spacecraft and the rocket, or what's left of the rocket.
The voice also reported the shutdown of the small rocket engines for the correction, a small correction of the orbit to make it more accurate.
What does that indicate? What does that tell us?
Because the YF-75D have a very big thrust, so we need small engines to correct the final orbit to make it more accurate.
So and that means it's already in orbit.
It's already in orbit. We're now about 36 minutes into the flight. We understand the spacecraft is already in orbit. We're waiting to hear official announcement about the flight.
Well, you can see
from command.
From the image, you can see this spacecraft is very, very stable in relative to the Earth. So now there's a separation.
The separation of the spacecraft and the rocket. This is a crucial step in the flight, indicating now that
the separation is confirmed by the telemetry data, which can be checked and examined from the ground and also from the camera. We can. This is a video from mounted on the end stage of the rocket, and we can see you can see the thrusters of the orbiter of the Chang'e 5.
So the spacecraft is now on its own, which is what we intended for.
So
it's now in orbit.
So the next, So the next critical step will be the unfolding of the solar panels of the orbiter. With this step, we will have continuous power supply to the spacecraft.
And we can see the unfolding of the solar panels, right? Do we have cameras that will show us the unfolding of the solar panels?
I suppose so. So we also, as we have discussed, we need the telemetry data to be transferred to the ground. So this is still the engine from the rocket.
So basically, in layman's words, we're fine-tuning the spacecraft as it hits that orbit now. It looks like we still need a couple more minutes until everything is in place and we might hear an official announcement about the status of the flight. Let's talk more about what's going to happen with the main mission this time, the sampling and the returning of those samples. What about the challenges of the return capsule? We know that they will return to Earth, they will re-enter the atmosphere at very high velocity, and then it will land in grasslands in Inner Mongolia. I suppose that's what's going to happen. Talk to us about the potential challenges there.
You know that we choose to recover our re-entry capsule in the mainland of China. You know that the difference from the manned missions from the low Earth orbit is that we don't have much choice, and also the window is very, very narrow.
Professor Yang, are those the solar panels we're seeing there?
No,
I can't quite make. So the solar panels have not been.
So we still need the report from the ground staff to report this.
I'm sorry for cutting you off. Please go ahead.
So to achieve this goal, we choose what we call the skip re-entry, which means that the spacecraft, the re-entry capsule, will not descending to the ground directly. It will descend from the outer space to about the altitude of about 60 kilometers high, and then raise its trajectory to go back to outer space again, and then going down. To have this kind of measures, we can adjust the landing point in a very wide range. So with this measure, we can land this spacecraft to our mainland of China, or otherwise we will have to recover this spacecraft in oceans. So you see, the United States choose the oceans to recover their Apollo spaceships, but we don't. You see that this needs a very large-scale rescue ships, rescue fleet. So we choose this, which can reduce a lot of the cost, but this makes the complexity of the mission itself. You know that the re-entry capsule is a very small one, much smaller than the Chang'e spaceship. So the tracking of this re-entry capsule is very difficult. You see that tracking so small spacecraft like this Chang'e 5 re-entry capsule with a speed nearly 11 kilometers per second is very, very difficult. We have experienced this during the Long March 5 T1 missions, but that's very successful. And also, this kind of trajectory tracking will be very critical for us to get a very precise prediction of the landing place, and also to have the rescue teams to the place at the first moment.
And Mr. Xu, before I get to you, help us understand what's happening here with this picture.
Well, this is what we call the separation of the spacecraft with the rocket itself. So the spacecraft is in a status where it has integrity checking, self-checking, and also sending signals back to Earth and waiting for the command to deploy the solar panel. So we have just heard from the command control center they have received some information from the TTNC ground stations. So they will very soon send a TTNC signal to the spacecraft once everything is validated, and then it will deploy the solar panel and readjust its attitude with the attitude control systems, either small propulsions or gyros. So it will then face a period of time where it will orbit in the equator orbit of the Earth, and then accelerate later on to the translunar orbit.
How long until that acceleration?
It will take a number of circles around the Earth, and then validate everything and make sure that the spacecraft is ready. I think is in 1 or 2. Within 1 day, I think it will send a signal, and then it will go to the translunar orbit.
So basically, information and data as we speak are being sent and validated by ground controlling command. After they do that, they can give instructions to deploy the solar panels.
As you see that this spacecraft is not always above the Chinese territory, so we're using a lot of overseas TTNC networks. The deep space network of ESA has been used for these cooperations, including the cooperation with the European Space Agency and Argentina is part of this effort. So we're using overseas telemetry tracking control stations in connection and linkage with the Chinese network, so that we can have a constant monitoring and control of the spacecraft. This is very important, very precious cargo of our nation, so we have to keep an eye constantly on this spacecraft.
That's definitely what we'll continue to do here on our program, keeping a close eye on the Chang'e 5 mission. Professor Yang, Mr. Xu, I want to thank you so much for your expertise, your explanations, and your insight today on our program. Thank you so much. And that'll do it for our special coverage of the Chang'e 5 launch. In the following days, the spacecraft is expected to bring back the first batch of lunar soil and rock samples in over 4 decades. Stay tuned to CGTN for the latest on Chang'e 5 as it makes its way to the moon. I'm Zhong Shi in Beijing. On behalf of the entire team, thank you so much for the privilege of your time.
时间，纵4时3纵分，216。